All right, welcome back, everybody, for another deep dive. You might have seen some headlines about this super cool new image from the Hubble Space Telescope.
Okay.
But today we're going to dive a bit deeper than the news cycle allows, right?
Right.
So we're talking about the Small Magellanic Cloud. And get this, you can actually see this galaxy with the naked eye.
Wow.
Pretty amazing, right?
Yeah.
We're about to find out what Hubble's powerful lens reveals about our galactic neighbor.
All right, so the Small Magellanic Cloud, or SMC for short, is a dwarf galaxy. Basically, that means it's smaller than your average run-of-the-mill galaxy.
Okay.
It's one of the Milky Way's closest companions. It orbits around us at a distance of about 200,000 light years.
Hold on, wait. 200,000 light years away, and we can still see it
Yeah,
without a telescope.
you can.
I need to, wrap my head around that for a
It's
second.
amazing.
So what would I be looking for exactly?
On a clear night, far away from city lights, it appears as this faint smudge of light, almost like a detached piece of the Milky Way.
Huh, interesting.
Of course, Hubble's view is infinitely more detailed, revealing intricate structures and processes happening within the SMC that we could never see with just our eyes.
Okay, so let's talk about this Hubble image. How did they capture such a stunning view?
So they used Hubble's Wide Field Camera 3, or WFC3. This camera is incredible because it can capture images through different filters, each isolating specific wavelengths of light.
Okay.
Think of it like this. One filter might capture infrared light, which allows us to see through dust clouds, while another might capture ultraviolet light, revealing the hottest, most energetic stars.
Oh, cool.
By combining data from all these filters, they create a multicolored composite image that's packed with information.
So they're basically piecing together like a puzzle of different light wavelengths to get a complete picture.
Exactly. In this case, they used 4 different filters, giving us an incredibly rich view of dust clouds drifting through a vast field of stars. They focused on a region near the center of a star cluster called NGC 346, which is known for being home to a lot of massive young stars. And this is where it gets really interesting.
Okay, I'm all ears. What's so special about this cluster and its stars?
Astronomers observed these young stars spiraling into the center of the cluster. This isn't something you see every day, and it suggests stars are forming in a very unique way in NGC 346.
I'm trying to picture this spiral of stars. What forces would even cause that kind of motion?
Think of it like a river of gas and stars flowing towards the center. The outer arm of this spiral seems to be funneling material inward, feeding the star formation process. This is a remarkably efficient way to create new stars. And it has astronomers buzzing.
So it's like a cosmic whirlpool.
Yeah.
Pulling everything towards the center. But wouldn't that mean that the cluster is aiding itself?
Right.
How long can that process even go on?
It's a delicate balance, The cluster is forming stars at an incredible rate. But this process can only continue as long as there's material to feed it. Eventually, the gas and dust will be depleted, and star formation will slow down.
Okay, so this spiral formation is fascinating.
Yeah.
But it's just one cluster, right?
Yeah. Can
we really draw conclusions about star formation in general from this one example?
That's a great question. And you're right to be cautious. It's true that NGC 346 is just one cluster. But what's exciting is that this observation challenges our existing ideas about how stars form.
Oh, but
it suggests that this river-like motion of gas and stars could be more common than we thought. And that might change how we model and understand galaxy evolution as a whole.
I always assumed star formation was a more chaotic, random process. This spiral makes it seem so organized.
There's definitely a sense of order to it, and that's what makes it so intriguing. It suggests there are forces at play that we don't fully understand yet, forces that can sculpt and direct the flow of matter on a galactic scale.
Okay, so maybe this cluster isn't a one-off. But why should we care about what's happening in a galaxy thousands of light years away?
Right.
What does it have to do with us here on Earth?
It's easy to think of distant galaxies as totally separate from our own little corner of the universe. But the truth is, studying these galaxies, especially those close enough to observe in detail, like the SMC, gives us a window into the past.
A window into the past. How so?
Because light takes time to travel. When we look at the SMC, we're seeing it as it was 200,000 years ago.
Whoa.
That means we're witnessing star formation processes that happened long before our own sun was even a twinkle in the cosmic eye.
So we're essentially looking back in time to see how stars were forming when the universe was younger.
Precisely. And by studying these ancient processes, we can gain a better understanding of how our own galaxy and ultimately our own solar system came to be.
It's mind-blowing to think that those distant stars hold clues to the origins of everything we know.
I know, it's really amazing.
But I have to ask, is there a practical application to this knowledge? I mean, does understanding star formation in the SMC have any impact on our lives here on Earth?
It might not have immediate day-to-day applications in the same way that, say, medical research does. But on a fundamental level, understanding star formation is about understanding the building blocks of the universe, the elements that make up our planet, our bodies, everything we see around us were forged in the hearts of stars.
Wow, so when we look at those stars, we're essentially looking at the source of our own existence.
Exactly. And by studying how stars form, we're peeling back the layers of cosmic history and gaining a deeper appreciation for the interconnectedness of everything in the universe. From the smallest atom to the largest galaxy, we're all part of this grand cosmic story.
That's a beautiful way to put it. It makes you realize that studying the SMC isn't just about collecting data points. It's about connecting with our cosmic heritage.
Absolutely. And for me, that's what makes astronomy so captivating. It's about exploring the unknown, pushing the boundaries of our knowledge, and ultimately searching for our place in the vastness of space and time.
You know, for a long time, I thought astronomy was just about memorizing constellations and planets. I never realized how profound and interconnected it all is. But let's bring it back to this specific image for a moment.
Sure.
What are the key takeaways from this observation of NGC 346? Why is it so important?
This image is a game changer because it provides the clearest evidence yet of this river-like star formation process. And what's even more intriguing is that the SMC is a relatively primitive galaxy.
Primitive? What do you mean by that?
It means that the SMC has a lower abundance of heavy elements compared to galaxies like our own Milky Way. And that's important because the early universe was also low in heavy elements.
Sure.
So by studying star formation in the SMC, we're getting a glimpse of how stars formed in the early universe billions of years ago.
So it's like having a time machine to study the universe's baby pictures.
Exactly. It's a unique opportunity to observe star formation in an environment that resembles the conditions shortly after the Big Bang.
I'm starting to see why astronomers are so excited about this.
Yeah.
It's not just a pretty picture. It's a portal to the early universe.
And it's a reminder that the universe is constantly evolving, changing, and full of surprises. What we see it today in the SMC is a snapshot of a dynamic process that's been unfolding for billions of years. And who knows what other secrets are still hidden within those swirling clouds of gas and dust.
That's what I love about astronomy. It's a constant reminder that there's always more to learn, more to discover, and more to wonder about. And sometimes all it takes is a single image to spark our curiosity and set us on a path of exploration.
Yeah, it really makes you appreciate the power of these telescopes, to think that we can peer across such vast distances and witness events that happened billions of years ago.
I know, it's incredible.
It's just incredible. It's humbling, really.
It is. It's truly humbling. And to think this is just one small patch of sky. Imagine all the other wonders that are out there just waiting to be discovered.
It makes you wonder what future telescopes will reveal.
Right.
I mean, if Hubble can show us this much, what will the next generation of telescopes be capable of? Oh, the possibilities are, like, mind-boggling. We have the James Webb Space Telescope, already sending back breathtaking images, peering even further into the universe's past. And there are even more ambitious telescopes in development, like the Extremely Large Telescope, being built in Chile. They'll be able to gather even more light, see even fainter objects, and resolve details with even greater precision.
So we're on the verge of a golden age of astronomical discovery.
Absolutely. We're entering an era where we'll be able to answer questions we haven't even thought to ask yet. It's an incredibly exciting time to be an astronomer. I think anyone who's even remotely curious about the universe should be paying attention.
I know, I'm hooked. So to wrap things up,
Yeah.
what would you say is the most important thing for our listeners to take away from this deep dive into the Small Magellanic Cloud?
I think the key takeaway is that even something as seemingly insignificant as a faint smudge of light in the night sky can hold profound secrets about the universe. The SMC is a reminder that there's so much more out there than we can see with our naked eyes, and that every new discovery brings us closer to understanding our place in the grand scheme of things.
Beautifully said. So the next time you're gazing up at the stars, remember that faint little cloud we talked about at the time capsule, a star factory, a glimpse into the early universe, and a testament to the power of human curiosity. Thanks for joining us on this deep dive into the Small Magellanic Cloud. We'll catch you next time for another cosmic adventure.